Local productions seen on Delta College Public Media are made possible with support from viewers like you. Thank you.
Hello, everyone. Welcome to Junia Doan's The Spark. I'm Junia Doan, and thank you for joining us. My guest today is Dr. John Krupczak, professor of engineering at Hope College and author of Understanding Technological Systems, an engineering book for the non-scientist. Welcome, John. What exactly is engineering encompass?
Great. So a lot of different definitions out there for engineering. So the one I'd like to suggest is it's creating systems to transform available inputs into outputs. So if you think of an automobile, the available inputs are gasoline, and the desired output is energy of motion of the vehicle. So engineering is creating the system, all the internal components of the automobile to convert what you have into what you want. In the case of, say, a cell phone, engineering is creating that device which takes an available input, the signal, and produces a desired output like the video display on the screen and the audio output from the cell phone. So one way to describe engineering is creating these systems of interacting components to convert inputs into outputs.
So that's very interesting. So when they say reverse engineering, it's taking a product and trying to figure out what part of the system or where the system was that made the product success or made the product.
Sure, in reverse engineering, we have the final product, and we know the inputs and outputs, but what we don't know is the internal components and how they interact to convert those inputs into outputs. And a lot of consumer products are pretty complex systems with a wide variety of potential outputs and a wide range of inputs. So reverse engineering all the different pathways between inputs and outputs uh, can be a complex task. In some ways, reverse engineering is thinking about how does something work. In other words, we have the product. We want to know, okay, beyond just the part that we can observe, what it looks like, how do these components interact? What's each component doing? One way to think of it is like a team, right? If you're looking at a team sport like football or baseball, the players are interacting in some way to achieve the purpose, the goal, and each player has a certain function or job. Just like in an engineered device, the various components have their role to play in getting the overall system to accomplish its goal.
One of the things I was thinking about when I was thinking about reverse engineering and even engineering was once you understand that, you then can figure out options so that they do something different rather than the outcome you originally aimed for. I mean, you learn, I'm guessing, I'm asking more than guessing maybe, that once you understand it at that level and what each component could do, you could find opportunity for enhancement or miniaturization or just a variety of things.
Yeah, absolutely. Like one example would be the refrigerator. So you have the big refrigeration system, but the air conditioner is really a refrigerator with one component stuck out the window. So if you have the basic system intended to cool a box to keep food cold, then exactly as you're suggesting, then a relatively minor modification can adapt it to a different application. Or as you suggested, it can be made larger or smaller. So the basic system that's a domestic kitchen refrigerator is keeping the entire freezer section of the grocery store cool. It's just scaled to a different um, magnitude of inputs and outputs. But you're absolutely right. Is the adapting of the system to uh, a slightly different application is really a key aspect of engineering. And it kind of comes down to not reinventing the wheel, but modifying the wheel, right? So there's lots of different types of wheels, whether it's an automobile wheel or a skateboard wheel, but they're adapted to different circumstances, different applications.
So when I was a young girl, I was lucky in that I came into a convertible, but it only had speakers in the front, and you know, kids like noise. But I was convinced if I could find a way to get speakers in the back, then I could have surround sound. And at that time, I was living with my grandparents in Oklahoma. So I would drive to the garages in town and ultimately further and explain my idea. And they say, oh, it couldn't be done, never heard of it. Why would you want to do it? No, can't help. But I kept at it. I kept at it. I didn't understand why I couldn't have that. I didn't have the technology to do it myself. However, I was really lucky in a very remote, small town with a tiny garage. I found a guy who was willing to try and do it. And so I had four speakers in my little car very early on. And I think the role of imagination can drive the technical side too. But also, until you understand the technical side, you're restrained. So, is there a process from engineering that applies to life?
Yeah, I think the idea of a system is a good takeaway from engineering that can be applied in other circumstances. So, particularly in technology, this idea that the system consists of components that do part of the they solve part of the problem, and those components interact in some way to achieve the overall solution. And in technology, it's, I think, particularly easy to see that because the components are pretty well defined. Like in your case, well, we have the, the radio system and the output to the speakers. So the speakers take the signal and produce sound. And you're right to conclude that, well, what's to stop another signal from going to another set of speakers and also reproducing sound? So the idea of being able to understand what the component elements are doing, how they're interacting, I think is an important takeaway from engineering into other spheres of life where we have systems, but the components may not be as obvious. Like if you think about a legal system or a political system, or uh, particularly in organizations, uh, division of labor, different types of interactions are really systems. But unlike in technology, where you can actually look and put your hands on and touch, okay, this is the particular component that's carrying out this function. Like in your case, the speakers were the component that's taking the signal and producing the sound. In other systems, it may not be quite as obvious what the components are or what their interaction is. But if you have that mindset, saying, well, there's something going on here, and it's likely a system. So if I can identify what those components might be, identify how they're interacting, then you gain an overall big picture of of how the whole thing works. So I think and it's also, I think, as in your case, somewhat intuitive. I mean, I think people's brains have a way of thinking along these lines, and if it's not so much like learning that, but just activating what might be a natural way of analysis, saying, okay, uh, this particular situation is a system. So how do I identify the inputs? How do I identify the individual components or elements? How do I identify the interactions? So applying that kind of framework to analyzing a given circumstance.
I learned myself from that and also later experiences that just because someone else couldn't do it doesn't mean it couldn't be done. And, you know, what
I think
did you need to do? And inevitably, you know, that goes to a lot of sides of life, you know, and then they either call you crazy or, you know, sees the future or what have you, depending. Um, but I'm really taken. I just recently read an article about it was in a science magazine, but it had to do with how people think. And the woman who wrote it So there are three types. There's basically, I'll call the intellectual facts and sequence and so forth. And no feeling, no anticipation, no hint, no idea, no nothing. The second group is more about intuition and fact. And the third group is a meld of those. So I sat around thinking and I kept saying, I wonder how this applies to research that has taken place. If you're from one type of thinking or the other, you come out with one kind of answer or another. So the intuitives may not have gotten, or they may have gotten three other ideas from it. It's just interesting. And I sort of feel that when you talk about a system, somehow that intuitive or the goal or the whatever um, maybe needs to be taught. But what did you teach in your book? I tried to get a copy. It's big, but I didn't get a copy to read the chapters, But tell us, because I thought you were very brave, and it's necessary to talk to people who are scared of engineering, or scared of math, or scared of computing, or scared of thinking.
So the idea of a system, I think, is useful in understanding something that appears complex, like a cell phone or a computer or an automobile. And when I started teaching this class, one of my students made the observation that before using a systems approach, they thought of the car as one big machine, just one entire complex unit, which it is. But the system idea is that this complex unit is made of subunits which can be understood individually and then assembled together. So we can take an automobile which has, maybe 15,000 individual pieces and think of it as seven main systems and look at that each system individually. So it's a divide and conquer approach, which is really a natural way of thinking. And it also reduces the anxiety factor when you think about a complex technology. Okay, we isolate most of it and look at one part, understand that, and then we put the parts together. And it's really a natural way of thinking. So accessing that framework, I think, helps people to understand technological systems. And when you have problems, then it's an issue of, well, which of the subsystems is likely to be causing the symptom versus the entire unit is at fault. So
Well, take
similarly,
a cell phone, for example. If your cell phone has problems and you had a non-technical person like myself, what would be the first questions to ask yourself?
so usually it's the things like, well, is it power? Like, do you have power? And then what about the input? Do you have a signal? Do you have an indication of a signal? And then you think, okay, what's the next likely thing? Well, maybe it's some internal processing. So cell phone is complex, lots of options, trying to reduce the potential options and look at like some basic functionality. So can we get a basic subset to work? Um, like, is the camera working, which is a standalone system? Is the flashlight working? If those things are working, then we have an indication that the power is probably okay. So I think the idea is trying to work through the chain, which goes from the inputs to the outputs, and try to identify, okay, what's the likely subsystem that could be responsible. Uh, that I think is a fairly natural way that humans think, and so accessing that mode of thought in a technological context, just like any other context, is one figure out to debug a problem.
So no one should be afraid of technology. Just ask
No,
the right questions.
yeah,
How do you
yeah,
teach integrity? Or because if you're so good at tech, there's a high side to life and a dark side to life.
right. So there's the idea of the design intent, and then there's the actual application. So the cell phone may have been intended as a communication device, but as we're finding out, it can also be used as a spying device because it's able to access your behavior patterns and make those behavior patterns available to someone else. So the design intent communicating between individuals uh, actually leads to another application that the user may not be fully aware of.
Tell me a little bit about your upbringing when a lot of these technical things were not around, like stereophonic sound for me.
Yeah, it's interesting to think about how did we get by without text messages? We certainly did, but I can't really remember it very well. It's how effective it is.
Were your parents very interested in having you read the encyclopedia, do experiments at home, pushed athletics? What were the values of your family?
My father was an engineer and was a very hands-on person and had a lot of projects going on around the house. So I was just naturally involved in these things, and I was also benefit benefited from my family had a manufacturing business. So from a very young age, I was in the business, which involved machinery. My grandmother was always working on the machines, and as a kid, you kind of around those things and kind of pick things up. So I think it was a rich environment, and also one that the inner workings were available to me to learn in a unpressured way. Just kind of, being around the factory as a kid was one way to pick these things up. And my dad was very patient and explains, and my grandfather as well. Explaining things.
That's a real gift. I mean, to teach through positive activity and to be patient. I'm still trying to learn that myself. That's just, and you do the same thing with your own children?
Well, I tried. I think they were both interested in hands-on things, and um, since it was something I was comfortable with, we did a lot of little projects like that. So I think I tried anyway. As a parent, you never quite know. So
Yeah, that's true. They come ready to be who they are,
right.
in a subsense. What I find is that there's role reversal. Like a lot of technical stuff, my grandson is enchanted with and gets very impatient with me if I don't immediately know that, having learned it in some magical past. And when he shows me, he's not a good teacher, he just does it. And I said, how am I going to learn if you don't explain it more clearly and slowly? And he just thinks, well, what kind of an idiot is she? That it takes, but until you understand something, you can't go forward. So you might as well just take the time to get the first thing clarified. Anyway, the way I look at it. So, are your students different than the ones you had in earlier times? Are their interests different?
Well, I think some of the usual things. When I first started teaching, cell phones weren't as readily available, so like instructions and things tended to be involve more words. So now that we have cell phones and able to produce videos, I've migrated to more video based explanations and like lab instructions, which used to be strictly text, now can incorporate images and short videos. So that's really been, I think, in some ways, made the job easier because in terms of explaining technology, we can use these technological systems to capture aspects of explanation, which would be hard to explain with just the old-fashioned text and maybe a few sparse illustrations.
How does artificial intelligence and this big wave of fascination um, affect your teaching right now? Does it play into it in some way?
Yeah, it's interesting. I think there's one advantage here is that the artificial intelligence systems aren't quite able to identify systems themselves yet. So in terms of explaining how something works, a technological system, the AI I think is able to include some of the explanation, but being like the human agency of being able to look at a complex system and break it down into its elements, I think is still an area where we humans have a edge. And then also the synthesis, like you mentioned, analyzing the problem with the speaker. So that's a novel problem, and humans are good at solving novel problems. Artificial intelligence is good at um, accessing problems that have already been solved. So that also gives us humans at least an edge for now in terms of uh, being better at solving novel problems versus being able to access a catalog of already solved problems.
Hmm. What does that mean to access novel problems?
So if if someone's already solved the problem of how to add a speaker to a car audio system, then artificial intelligence can find that documented solution and say, okay, here's how you would address this issue. But if that problem has never been solved, then the artificial intelligence is not as adept, at least yet, as people are of envisioning potential solutions.
I always watch not always watch, but I'm interested in the development of machines, measurement machines. Like everybody used to use a slide rule who was an engineer, and that's gone. It's a historical element at the moment of fabrication of answers, or not fabrication, but measurement. And I wait in science and others when that part of instrumentation comes forward, more things are possible. I like design, and there's always measuring the rooms and measuring the wall. Well, all of a sudden there's an app a couple of years ago where you just shoot a beam at a wall and it will tell you how many feet away it is and what's the height. And I mean, it's just uh, it's just a great gift, but it also speeds up things. And sometimes I feel so much to know and no time to think about it. Where the important part is not necessarily the knowing, it's the thinking about it. How you're going to apply it, how you're going to protect it, where you're wasting time. It's uh, it's a different time. Sometimes I think in my own life that I need to just block out time for random thought, on whatever thing I want to do that's sort of deep or deeper. And because I think that's where the nuances are. Um, you can
Yeah,
measure a lot, but then there's, shading you might miss if you're not aware of it or looking for it. Or the one effect on a society that concerns me is how rapid answers come technologically. And does that make us not necessarily impatient, but just vacuous? We take the first answer, that's done. We don't really spend time thinking about what else, or could it be this way or that way, and therefore, what other ideas do you have? But everyone has to live in their times, and everyone learns to make the times work for them. So it's probably not something that I ought to be thinking about. Do you think?
yeah. Well, certainly, like the devices you mentioned. I mean, the goal is maybe to replace some of the what might be considered drudge work, like on the floor of the tape measure, trying to measure out the dimensions of the room. So that's work that can be replaced by technology to relieve you of that burden. And the idea was to, okay, now make time available for you to do the more complex tasks, like if you're looking at the interior design, like you mentioned, like shading or color combinations or other aspects of the design that aren't as routine, that can be replaced by technology, like the measuring system. But as you point out, maybe we're not as humans taking advantage of the time that the technology makes available to us, right? So we're supposed to be using the displaced time for uh, like more human type of activities versus the um, like the more simplified tasks that can be replaced by machines. Maybe we're not doing that, as you mentioned.
Um, I just believe in people when, at least under the American system, that when they get too much in one direction, they start getting uncomfortable and saying, is this the way I want to live? Or what am I missing here? Or is the dazzle enough? Or just whatever. And there's some, maybe over 50 years, a correction that it swings. But who exactly can say sometimes you just have to be super patient and maybe it's not in your lifetime. That's why I want to live a really long time. I want to see how everything plays out. Anyway, thank you so very much for being part of the Spark and for teaching us about engineering. That engineering is very comforting because it can help explain how things work, not only the mechanics of the electronics or just how furniture is built, um, but that once you have that kind of confidence, I think it bleeds over into the rest of your life, that you have confidence that you can analyze and correct or at least deal with situations that are perhaps not measurable. So I'm very grateful for you trying to deal with people like me who aren't technical and who are bringing a sense of calmness through competency. I'm glad for that. I'm glad to your father too. Is such a great teacher through his mechanics and machines and attitude of patience. So thank you again for being part of this, and I will see you all next week.
Thanks very much. Thanks for having me.
To contact Junia, send her an email at juniadonsthespark@gmail.com. For more information, program schedules, and news about future guests, go to www.juniadonthespark.com. Thank you for joining us. See you next time on Junia Doan's The Spark.
Local productions seen on Delta College Public Media are made possible with support from viewers like you. Thank you.